Space is big. You just won't believe how vastly, hugely, mind-bogglingly big it is. I mean, you may think it's a long way down the road to the chemists, but that's just peanuts to space. Douglas Adams. It's funny until it's not. Because once you let that line really sink in, something strange happens. You stop laughing. You feel it tug at the edges of your reality, like your mind just bumped into a wall it didn't know was there. Tonight, we're going to push straight through that wall. Welcome to Late Science. This is not just a video, it's a journey, a slow, expanding meditation on one simple, impossible question. How big is the universe? Not in numbers, not in statistics, but in something you can actually feel. Because if the universe really is as big as we say it is, if it's growing faster than the speed of light, if it holds trillions of galaxies, each with hundreds of billions of stars, if it's been around for nearly 14 billion years, then what does that make you? What does that make your life, your problems, your plans, your breath? Over the next few minutes, we're going to zoom out, farther than your brain wants to go, farther than it can go, at least without breaking a little. We'll begin with the ancient stargazers, move through early telescopes, modern science, and the invisible edges of the observable cosmos. But we'll also dive into the emotional fallout of confronting scale, because numbers are cold. Perspective is personal. If you feel your sense of self start to dissolve, if something inside you stirs with awe or fear or wonder, then like this video. Comment with the moment that hit you hardest, and subscribe to Late Science, because this is only the beginning. Now, take a second. Look around the room you're in. The walls, the furniture, the objects you own, the planet spinning beneath you. All of that exists inside a galaxy, spinning inside a filament, stretched across a universe that's expanding so fast, light itself can't keep up. And we're going to trace it all, one part at a time. In the beginning, there was light, but before that, there was silence. Let's begin. There's something visceral about standing under a truly dark sky. Without streetlights or building glow, the Milky Way spills overhead like a river of diamonds, each star twinkling with age and distance. In that moment, you might feel your pulse slow, your usual concerns dissolve, and a quiet clarity take their place. Psychologists call it awe, an intense emotional state where your sense of self shrinks and your sense of connectedness expands. It's more than poetic, it's physiological. Blood pressure lowers, heart calms, and stress retreats into the shadows. That feeling is no coincidence. Researchers have found that this emotion triggers the release of calming hormones, quiets internal chatter, and even lowers markers of inflammation. In studies, people who regularly seek out awe through stargazing or natural beauty report less anxiety, more happiness, and a deeper sense of meaning. And it isn't limited to remote wilderness. Just a few minutes gazing at rooftops and city stars can still spark the same mental shift. This emotional release is essential. When we approach cosmic scale, when we begin to discuss light years and galaxies, our brains need to unclench. If your mind is stuck in daily stress, the numbers bounce off your awareness like static. But in this calm openness, each figure becomes a revelation. You start to breathe with the universe. That's why part 2 isn't about measurements or history. It's a ritual. It's preparing your heart and mind to receive the grandeur at the core of this journey. As you sink into that awe, your world shrinks, your clothes, your commute, your arguments into a silent backdrop, and the cosmos opens. This resets anything that stood between you and wonder. Now you're not just watching a video, you're stepping onto a shared platform of astonishment. From here, every cosmic revelation will resonate deeper. You'll not only understand the scale, you'll feel it. In the early 1800s, the cosmos still whispered its secrets without revealing its scale. Telescopes had sharpened our view, but the true distances to stars remained elusive. How could anyone grasp light years using nothing more than geometry and patience? Enter Friedrich Bessel, a methodical German astronomer. Around 1837 to 38, he turned a powerful new instrument, the Fraunhofer heliometer, toward a faint, fast-moving star called 61 Cygni. With this precise device, he measured tiny shifts in the star's position caused by Earth's orbit, an effect known as parallax. Imagine measuring an object so distant that its shift mirrors the movement of a tiny coin seen from miles away. Bessel logged over 100 careful observations across seasons. By comparing the star's position against distant background stars, he detected a minute wobble, just a few hundredths of an arcsecond. From that, he calculated a distance of about 10.4 light-years, an astonishing first. The universe now had measure. Soon after, other astronomers confirmed stellar distances. Thomas Henderson measured Alpha Centauri from South Africa, and Wilhelm Struve charted Vega. But it was Bessel's parallax of 61 Cygni that set the cosmic scale firmly into human hands. This wasn't just data, it was a portal. Triangles and patience transformed the night sky into a quantifiable domain. Suddenly, distances once imagined became numbers, still vast but within the grasp of human minds. That foundational feat, measuring one star, paved the way for astronomers to build longer ladders. From nearby stars, they would ascend through techniques like Cepheid variables, supernovae, and redshift, each rung pushing us farther into the deep cosmos. But for now, this is where it began, with Bessel's quiet persistence under Königsberg skies, defying human intuition. He taught the world that cosmic distances could be known, bridging empty space with geometry and resolve. Building on Bessel's breakthrough, astronomers realized they needed a brighter, more distant ruler to reach galaxies beyond our Milky Way. That ruler came in the form of Cepheid variable stars, pulsating beacons whose brightness flips on a reliable rhythm. These stars, discovered in the late 19th century, pulsate with a period directly tied to their intrinsic brightness. Measure how fast they brighten and dim, and you can deduce their true luminosity. Then compare that with how bright they appear, and voila, you get their distance. In the 1920s, Edwin Hubble used this technique to resolve a cosmic mystery, the nature of nebulae like Andromeda. By spotting Cepheids in Andromeda and calculating their distance, he showed that these nebulae were not part of our galaxy. They were entire galaxies themselves, each containing billions of stars. That meant the universe was exponentially larger than anyone had imagined. This was a revolution. We went from knowing distances to a handful of nearby stars to gauging entire galaxies millions of light-years away. Cepheid variables, with their rhythmic pulse and predictable luminosity, became the second rung on the cosmic distance ladder, lifted by Bessel's first geometric step. As we peer deeper, we realize the universe isn't just vast, it's populated with countless cities of stars. Each Cepheid lights the path, anchoring distant galaxies to our expanding cosmic map. After Cepheid variables lit the path to nearby galaxies, astronomers faced a new challenge, measuring distances to galaxies so far away that no individual stars could be resolved. For that, they needed something brighter, something explosive. That something was the Type 1a supernova. These aren't ordinary stars. They're detonations, white dwarf stars in binary systems that steal matter from their companions until they reach a critical tipping point. When that limit is exceeded, the star collapses inward and then detonates with unimaginable force. The explosion is so bright, it can be seen across billions of light-years, often outshining an entire galaxy for weeks. But the most useful part? These explosions are reliably similar in brightness. Nature, it seems, gave us a cosmic flashlight. Because Type 1a supernovae explode under nearly identical conditions, they reach a nearly uniform peak brightness. This makes them perfect standard candles. Once astronomers know how bright the explosion should be, they compare it to how bright it appears from Earth. The difference tells them how far away the explosion happened. The brilliance of this method is that it extends our reach. We're no longer limited to our galactic neighborhood. With these supernovae, we can measure distances to galaxies billions of light-years away. Galaxies too distant and dim for even our best telescopes to resolve in detail. But there's more. These supernovae don't just give us distances, they tell us something deeper about motion. When astronomers charted the distance to many of these galaxies, they realized something shocking. The farther away a galaxy is, the faster it appears to be moving away from us. This relationship, distance and velocity, is the fingerprint of an expanding universe. It's what led to the formulation of Hubble's law. The universe isn't just vast, it's growing vaster with time. That realization shook the foundations of physics. The cosmos is not static, it's dynamic, stretching, growing, evolving. Every supernova flash, every measured distance, is a note in the grand song of expansion. This part of our journey changes the tone. We are no longer bound to a finite sky. The universe is not just big, it's becoming bigger. The stars are not fixed in a dome. They are hurtling away from one another in a silent, accelerating ballet. For decades, astronomers believed the universe expanded in the aftermath of the Big Bang, but the force of gravity would eventually slow that growth, maybe even cause it to reverse. That made sense. Every explosion eventually settles. Every stretch pulled by weight should strain and sag. but something wasn't adding up. When scientists used Type 1a supernovae to measure the distances and velocities of extremely remote galaxies, they noticed a terrifying detail. The farthest galaxies weren't just moving away, they were accelerating. The deeper you looked into space, the faster galaxies seemed to retreat, not in a straight line, not in a steady drift, but in a runaway expansion, as if space itself were being pulled apart by some invisible force. This revelation struck like lightning. The universe wasn't slowing down, it was speeding up. What could possibly be pushing galaxies apart faster and faster? It wasn't gravity, it wasn't matter, it was something else, something that didn't cluster, didn't shine, didn't slow. It became known as dark energy, not because it's related to darkness, but because we have no idea what it really is. Imagine blowing up a balloon, expecting the stretch to ease, only to find it stretching faster with each breath. That's what dark energy is doing to space, not only between galaxies, but between superclusters, between vast voids. It's not just carrying galaxies away, it's creating more space between them, making the distances unbridgeable. And here's the strangest part. Dark energy doesn't seem to weaken. It doesn't dilute as the universe grows. It persists. In fact, it dominates. Today, astronomers estimate that nearly 70% of the entire energy in the universe is this invisible accelerant. The stars, planets, dust, everything we can touch or see, makes up less than 5%. Let that sink in. Almost all of reality, by volume and by force, is made of something we cannot touch, see, or fully explain, and yet it defines our fate. This is the moment in our journey where awe turns to something deeper, unsettling curiosity. If everything is moving away from everything else faster and faster, what happens in the end? Will galaxies one day slip beyond our view? Will stars wink out forever? Will the sky grow dark, not from lack of stars, but from unbridgeable space? We're not just measuring distance anymore, we're measuring destiny. Once we realized the universe was expanding and accelerating, the next question was chillingly simple. How does this end? To even guess, we first have to understand how space itself might be shaped. It's easy to imagine the universe as a giant balloon or an endless plane, but space is more complex than any surface we can draw. Its shape isn't just geometry, it's destiny. Physicists broke it down into 3 possible forms: flat, open, or closed. If the universe is flat, like an endless sheet, expansion can continue forever, slowing but never stopping. If it's open, like a saddle curving outward, it will also expand eternally, only faster. But if it's closed, like a sphere, expansion might one day halt and reverse, pulling everything back together in a fiery collapse, the Big Crunch. For years, no one knew which shape we lived in. But thanks to precision measurements of ancient light, the cosmic microwave background, we now believe the universe is incredibly close to flat. Not perfectly, but within such fine margins that for all practical purposes, it stretches out endlessly in all directions. That would mean no edges, no center, just more space, forever. But flatness doesn't mean comfort, because the accelerating expansion means this flat universe is ruled by dark energy, and that changes everything. Imagine a universe where every second, more distance appears between galaxies, where light itself gets stretched until it fades, where stars drift so far apart that they vanish from each other's skies. In the far future, entire galaxies will slip beyond our cosmic horizon, disappearing from view forever, not because they're moving too fast, but because space is growing so rapidly between us that their light will never reach us again. Eventually, only the closest galaxies, perhaps just our local group, will remain visible. The rest will vanish into silence. This possible fate is called the heat death, a slow fade into cold, empty space. No explosions, no collapse, just distance. Infinite distance. Every particle spreads so far from the next that interaction becomes impossible. Even black holes evaporate. Even light forgets. It's a fate not marked by chaos, but by stillness. But there are other theories. Some believe dark energy might grow stronger, eventually tearing apart not just galaxies, but stars, planets, atoms themselves. This is the Big Rip. Others think dark energy may decay or reverse, creating cycles of expansion and collapse. Right now, we don't know. But what we do know is this: the shape of the universe and the force driving it apart is not just theoretical. It will determine how time ends. The numbers may say 13.8 billion years, but that's not a time any of us can grasp. It's a concept that lives outside our normal experience. When we say the beginning of the universe, it feels like we're talking about a moment, like an explosion you could have witnessed if only you were there. But this wasn't a moment within space. It was the moment space began. There was no outside to witness it, no edge it emerged from, no before, just emergence. The Big Bang wasn't an explosion in space, it was an explosion of space. Every atom, Every point of matter, every law of physics was born in that flash. At first there were no stars, no galaxies, not even atoms, just a searing soup of energy, hotter than anything the human brain can truly picture. The entire observable universe, now stretched over 93 billion light-years, was once smaller than a single grain of sand, and in that grain, time ticked its first seconds. In less than a heartbeat, the universe underwent a phase called inflation, a fraction of a second where it expanded faster than the speed of light, not in violation of physics, but because space itself has no speed limit. That inflation set the scale of the cosmos. It smoothed the wrinkles, shaped the patterns, and blew quantum fluctuations into the seeds of galaxies. Then came cooling. In the first 3 minutes, protons and neutrons formed. Hydrogen, helium, the basic elements of everything we know. Matter began to assemble. Gravity began its pull. And slowly, after nearly 400,000 years of darkness, the universe became transparent. Light could move freely for the first time. That first light is still out there, whispering in microwaves, faint but eternal. From that point, structures began to form. Clouds of gas collapsed into stars. Stars gathered into galaxies. Galaxies spiraled and danced and collided. From fire, form. From chaos, architecture. Billions of years passed. In one quiet corner, a small star formed, orbited by dust and rocks. One of those rocks grew oceans, life, minds, eyes that would look back and ask, where did we come from? And the answer is, from that beginning. From heat, gravity, and time. From nothing came everything. It wasn't random, but it wasn't planned. It was natural law, unfolding at unimaginable scale. And even now, every particle in your body carries a history that began in that moment. Every breath you take is made of atoms forged in the early fire. You are the residue of that great beginning. In the early universe, after the Big Bang's blaze cooled into darkness, there were no stars, just a vast silent expanse of hydrogen and helium gas. Gravity waited patiently. And then millions of years after that first light broke free, clumps began to form. Tiny irregularities in density, amplified by gravity, drew gas inward. The universe took its first breath of structure. These clumps collapsed, and when they did, the first stars were born. But these weren't stars like the ones we see now. They were giants, monsters by comparison, dozens or even hundreds of times more massive than our sun, burning with a brilliance we can scarcely imagine. They lived fast and died young, some surviving just a few million years, mere sparks in cosmic time. We call them population 3 stars, the hypothetical first generation. They were made from pure hydrogen and helium, the original elements created in the Big Bang. No carbon, no oxygen, no metals. In the language of astronomy, metals means anything heavier than helium, and these stars had none. They were truly primordial. Because of their massive size, these stars burned furiously. Their cores fused hydrogen into helium, then helium into heavier elements. But their weight was their doom. Many ended their lives in cataclysmic supernovae, or collapsed directly into black holes. They left behind no fossil record, no glowing remnants, only their ashes, scattered as heavier elements across the cosmos. And it is from those ashes that everything else formed. The carbon in your body, the iron in your blood, the oxygen you breathe, none of it existed before those stars. They built the ingredients of life in their fiery deaths. Without them, no planet would ever support life. No tree would ever grow. No thinking creature would ever stare upward and wonder. We have never seen one of these first stars. They died too long ago, too far away. Their light may have faded, or their remnants may lie hidden in ancient galaxies, cloaked by dust and distance. But we can infer their existence by what came after. Newer generations of stars filled with heavy elements, galaxies laced with dust, planets rich with complex chemistry. They were the universe's first alchemists. And the mystery remains, are any of them still out there? Could a small one have survived to this day, ancient and quiet, orbiting in some forgotten region of space? If so, it would be older than any known star, a relic from a time before structure, before light, before the universe we now know began to take shape. Once the first stars lived and died, the universe entered a new era. It was no longer just a sea of gas. It had history, it had heavy elements, and it had a sculptor, gravity. Gravity doesn't rush, it waits, pulls, builds. Over hundreds of millions of years, tiny clusters of stars merged, collided, and grew. What began as loose gatherings of starlight eventually became galaxies, vast, spinning cities of stars, each one a gravitational cathedral, built from the wreckage of stellar lives. Galaxies didn't appear all at once. They emerged slowly, through collision and cooperation. Early galaxies were chaotic, irregular shapes, small groups of stars with no symmetry. But gravity had time. Billions of years passed. Smaller galaxies merged, drawn into larger spirals and ellipses. Collisions weren't destructive, they were creative. Galaxies grew by devouring each other. Our own Milky Way is a product of that process. It wasn't born fully formed. It's the result of countless mergers, each one adding stars, dust, and structure. Even today, it's still growing. Our galaxy is in the process of absorbing smaller companions, like the Sagittarius dwarf galaxy. The dance never ends. Step back for a moment. Imagine flying above the cosmos. Below you, hundreds of billions of galaxies, each containing hundreds of billions of stars. Some spiral like pinwheels, others form giant ellipses. Still others are chaotic blobs. These aren't just isolated structures, they form vast networks, connected by invisible threads of gravity and dark matter. Galaxies don't float randomly. They align into filaments, forming the cosmic web, a vast lattice of matter stretching across the universe. In between, immense voids, places where nothing shines, where darkness reigns. This structure is breathtaking. It resembles neurons. High-speed simulations of the cosmic web look eerily like brain scans. Billions of galaxies arranged in patterns that mirror our own thoughts. Perhaps it's a coincidence, perhaps not. Inside galaxies, stars form in waves. Gas clouds collapse under their own weight, giving birth to stellar nurseries. Bright blue, short-lived stars blaze to life, illuminating spiral arms. Over time, the balance shifts. New stars form less frequently. Galaxies settle into quiet maturity. Some galaxies remain small, peaceful, drifting alone. Others collide, massive slow-motion encounters that stretch over billions of years. When that happens, stars rarely collide directly. They're too far apart, but their gravitational interactions reshape everything, triggering waves of star formation, distorting arms, merging black holes. And one day, we will witness this firsthand. The Milky Way is on a collision course with the Andromeda Galaxy. In about 4 billion years, they will begin to merge, not in violence, but in beauty. The night sky will fill with new arcs of stars. The galaxies will wrap around each other in a glowing spiral, and eventually, they will become one. This is the destiny of galaxies. Not isolation, but union. The cosmos builds through collision. It sculpts order from motion, and what began as scattered starlight becomes structure. The Milky Way. To the naked eye, it's a soft band of light across a dark sky, poetic, serene, familiar. But from above, if you could somehow float beyond its reach, you'd see a spiral hundreds of thousands of light years across, rotating like a cosmic whirlpool. 100 billion stars, circling a hidden heart. This is our galaxy. Our home, a flattened disk of stars, dust, gas, and memory. We reside within one of its spiral arms, the Orion Arm, nestled between two larger ones, Sagittarius and Perseus. That placement, modest and off-center, is a gift. It gives us a clearer view of the galaxy's structure, less interference, more access to the sky beyond. If we had been born in the crowded galactic core, the night sky might have been a blinding wall of starlight, beautiful, but obscuring everything else. The Milky Way rotates once every 230 million years. That means the last time the Sun was in its current position in this spiral dance, Earth was inhabited by early dinosaurs. Stars like our Sun orbit the galactic center at incredible speeds, around 800,000 kilometers per hour. Yet the galaxy is so vast, it takes them hundreds of millions of years to make a single loop. At the heart of the Milky Way lies a mystery, a supermassive black hole. It doesn't consume everything, but it defines the center. Millions of solar masses compressed into a space smaller than our solar system. We can't see it directly, but we see its influence on stars that orbit invisible points, on matter that spirals inward and vanishes, on radiation echoing from its borders. But not all of the Milky Way is dense or dangerous. Much of it is dust and gas, nebulae glowing with starlight, regions where stars are born. In these stellar nurseries, gravity compacts hydrogen until fusion ignites, and new stars emerge. Some live fast and die as supernovae. Others, like our Sun, burn steadily for billions of years. We are tethered to this spiral, part of its architecture. The atoms in your body were once scattered across this galaxy, fused in different stars, exploded into space, recycled in molecular clouds, and eventually gathered here into the form you now inhabit. Even now, the Milky Way is not alone. It's surrounded by satellite galaxies, small companions like the Large and Small Magellanic Clouds, orbiting like children around a parent. It's in motion, pulled toward its neighbors, eventually destined to merge with Andromeda in a titanic fusion of star systems. Yet we only see a part of it. A vast portion of the Milky Way remains invisible, shrouded in dust, or hidden by the very matter we ride within. And surrounding all of it is a halo of something else, something that doesn't glow but binds everything: dark matter. It holds the galaxy together, shaping its rotation, its structure, its survival. The Milky Way is not just a collection of stars, it's a gravitational symphony. It is the pattern that gave rise to planets, oceans, minds, questions. Drifting in one of the Milky Way's spiral arms is a star that doesn't stand out. It's not the brightest, not the biggest. It's young compared to many, a yellow dwarf among billions of others. And yet everything you've ever known, loved, or imagined exists because of this one ordinary star. We call it the Sun. The Sun formed around 4.6 billion years ago, from the collapse of a molecular cloud, just another swirl of hydrogen and dust, nudged into motion by gravity and maybe a nearby supernova. As the cloud condensed, its center ignited, fusion began. A star was born. But the Sun didn't arrive alone. Around it, a flat disk of gas and dust spun into structure. Over millions of years, particles collided and clumped, forming larger and larger bodies. Moons, asteroids, planets. 8 of them, along with countless smaller fragments, began orbiting the Sun in orderly ellipses. Earth was one of them. Our planet coalesced from dust and stone, heating under the pressure of its own gravity. Volcanic fury, constant bombardment, a molten beginning. Then, after a catastrophic collision with another protoplanet, Earth gained a moon, a stabilizing presence, a cosmic twin. But Earth wasn't special just because of its geology. It was its distance from the Sun, a perfect zone, not too hot, not too cold, that allowed water to remain liquid. And where there's water, chemistry becomes possible. Over time, carbon compounds danced in oceans, struck by lightning, heated by vents, nudged by time, and something emerged. The first cells. Life. Single-celled at first, barely more than molecules. Then complexity. Photosynthesis. Oxygen. Multicellularity. Eyes. Fins. Wings. Thought. Civilization. All of it powered by the Sun. Its energy warmed our seas, fed our plants, drove our weather, lit our skies. Without that constant distant nuclear fusion, Earth would be an icy, lifeless rock drifting in silence. But zoom out. Our Sun is just one among hundreds of billions in our galaxy, and our galaxy is just one among trillions in the universe. If this single average star could give rise to oceans and minds, what else might be out there? What other stars cradle worlds of their own? What other orbits might carry oceans, continents, life forms staring up at their own stars, wondering if they too are alone? The Sun is a local engine, but it raises universal questions. Its ordinariness is what makes it extraordinary. Because if something so unremarkable can give rise to thought and emotion, to cities and language, to you and me, then the universe might be bursting with stories. And we've only just begun to listen. For most of history, we believed Earth was unique, the only world, the center of everything. Even after we realized the Sun was a star among many, we still clung to the notion that planets were rare, that life, especially intelligent life, was a fluke. But then everything changed. In the 1990s, astronomers began detecting the first exoplanets, planets orbiting stars beyond our Sun. At first, they found giants, massive, bizarre worlds orbiting dangerously close to their stars, scorching gas balls nicknamed hot Jupiters. They were unlike anything in our solar system, exotic, but real. And then came more, dozens, hundreds, thousands. Today we've confirmed over 5,000 exoplanets, with thousands more candidates waiting for confirmation. These aren't just statistical blips, they're everywhere. It turns out that nearly every star in the night sky probably has at least one planet. Many have whole systems, some may have dozens. The techniques used to find them are subtle. We watch stars flicker as planets pass in front of them. We observe the tiny gravitational tugs they exert on their suns. It's like detecting a moth circling a distant street lamp by watching how the light dims for a heartbeat. From these delicate signals, we reconstruct other worlds. Some are gas giants, others are rocky like Earth. A growing number sit in the habitable zone, not too close, not too far from their star, where temperatures could allow liquid water to exist. We call these Goldilocks planets. Not too hot, not too cold, just right. These planets haunt us, because every time we find a rocky world orbiting in just the right place, our imagination runs wild. Could it have oceans, weather, life? Could it have evolved minds, cities, stories? Could someone there be looking back, wondering if they too are alone? But it's not just romantic fantasy. With instruments like the Kepler Space Telescope, TESS, and soon the James Webb Space Telescope, we're beginning to study atmospheres, to detect the fingerprints of chemistry, water vapor, even oxygen. Soon, we may be able to smell alien skies across the light years. The odds are shifting. Once we thought we were a cosmic miracle. Now, It's starting to look like the miracle might be the rule, not the exception. Life may not be rare. It may be inevitable, written into the physics of the universe, like gravity and light. And if that's true, the silence of the cosmos becomes more profound. Where is everyone? We'll ask that question soon. But first, we need to understand the scale we're working with. Because the nearest potentially Earth-like planet might still be 40 light-years away. That's unimaginably close on a galactic scale, and yet impossibly far for us now. We've talked about exoplanets, potential Earth-likes, worlds floating in the Goldilocks zone. But now let's get real. How close are they? What do their distances mean? Imagine this, a planet only 40 light-years away. That's practically our next-door neighbor on a cosmic scale. But in practical terms, it would take tens of thousands of years just with today's fastest spacecraft to get there. 40 years for light, but tens of millennia for steel. And yet 40 light-years is tiny, next to the galaxy's size, 100,000 light-years across. It's like measuring centimeters on a football field. So yes, we're practically neighbors in galactic terms, but practically it's unreachable. Then there are planets 100, 50, 100, even thousands of light-years away. Their starlight is old news, history arriving decades or centuries after it happened. If you saw something happening there, it might have already ended long ago. Here's the emotional hum. These worlds are near in scale, unimaginable in distance. We can see them, catalog them, study their light, but to touch them, still impossible. This tension that space can be small and huge is the heart of cosmic wonder. It's hope steeped in humility. It's the thrill of possibility tempered by reality. And it raises a question: what do we do with that? Do we wait for technology to catch up? Do we beam signals, build telescopes, try to listen? Do we imagine futures where we hop between stars, or find meaning right here? Over the next few minutes in this and upcoming parts, we'll explore those questions. We'll chart the silence between stars. We'll learn what we can know about those distant skies. We'll shine a narrative torch across space, time, possibility. Because as much as numbers describe distance, stories bring it home. We've measured distances, charted orbits, and found thousands of distant worlds. Now comes the real question. How do we look for life? Not just any life, but life as we might recognize it. First, we listen to the stars. Natural light holds secrets, fingerprints of molecules in alien atmospheres. With powerful telescopes, we analyze absorption spectra, hunting for biosignatures, oxygen, methane, water vapor. A whiff of oxygen may mean photosynthesis. Paired with methane, that's a chemical imbalance, often linked to life processes. Then there's the search for technosignatures, a fancy term for alien technology. Signals, structures, energy use, anything that points to intelligence. The SETI projects have scanned the skies for decades, listening for narrowband, repeating pulses, signs of radio transmissions or beacon signals. No definitive finds yet, but the search has only just begun. Closer to home, our probes and rovers dig into Mars, search for plumes on Europa's icy surface, and plan missions to Titan. They hunt for microbial fossils, subsurface oceans, and organic chemistry, the precursors or evidence of life. Each of these efforts is a step toward understanding our place. We're not just asking, is there life out there? We're asking, what does it mean if the universe is teeming with life, even microbial, or if we're truly alone? The answer changes everything. If life is common, then a spark of biology connects every world with it. Evolution becomes a universal story, not a fluke. If we're alone, then every living soul, every tree, every ocean on Earth becomes a priceless cosmic anomaly. Whether we find life or not, the act of searching shakes us. It reminds us that humanity isn't just looking. A part of us needs it. Because if we're not the only ones, what are we? If we are, what does that say about responsibility, purpose, loneliness? Over the next few minutes, through this part and into the next, we'll explore how these searches work, what they've taught us so far, and why nothing matters more than this question. Because in the night sky, each distant signal is a question echoed across space and time. Are you there? And our answer may define the story of life itself. In 1961, astronomer Frank Drake did something bold. He tried to estimate how many intelligent civilizations might exist in our galaxy right now. He didn't claim to know the answer, but he gave us a way to ask the question better. His tool? A deceptively simple formula, the Drake equation. It looks like math, but really, it's a mirror. Every variable in the equation reflects a deep uncertainty, a vast cosmic mystery. How many stars form each year in the galaxy? What fraction of those stars have planets? Of those planets, how many are Earth-like? How many of those could support life? Of those, how many evolve intelligence? And of those, how many choose to build technology capable of communication? Finally, How long do such civilizations last? The final number is a product of all of these multiplying possibility by mystery, and depending on what you plug in, the result ranges from 1 to tens of thousands. And here's the twist. Even if life is common, intelligence might not be, or intelligence might not last. Maybe most civilizations never survive long enough to reach out. Maybe they destroy themselves, or maybe they simply go quiet. That last term, how long civilizations send signals, is the most chilling, because it's not just about aliens, it's about us. If we expect others to survive and communicate for thousands of years, we must ask, will we? The Drake equation doesn't give an answer, it gives a frame. It tells us where to look, what we don't know, what matters most, and it forces a sobering truth. Maybe the galaxy is alive with signals, but we've only just started listening. Maybe we're early, or maybe we're shouting into a silence no one else escaped. Yet the silence isn't proof of absence. It's a question, a challenge, a haunting stillness that demands we keep listening. Because one faint signal from one distant world could change everything. There's a question that keeps astronomers awake at night. One simple, piercing question. Are we the only ones? Not in a poetic sense, but literally, out of the hundreds of billions of stars in our galaxy, each with planets of their own, how many have life? And how many of those worlds might have built cities? Radio signals, questions of their own. In the 1960s, scientists started pulling that question apart. They tried to trace a path from stars to planets, to life, to intelligence, not with hard numbers, but with filters, possibilities. How many stars form every year? How many of them have planets? How many of those planets are just the right distance from their stars, where water could flow, clouds could form, chemistry could spark? Then how often does life actually begin? And when it does, how often does it become something conscious, curious, capable of thought, speech, technology? And finally, once a civilization becomes advanced enough to send out a signal, how long does it last? The truth is, we don't know. Some of these steps might be easy, others could be impossibly rare. Maybe life forms often, but intelligence almost never. Maybe intelligence is common, but technology destroys itself. Or maybe they're all out there, right now, but too far, too quiet, or too early, or too late. It's like tuning an old radio, trying to catch a single whisper across a galaxy of silence. And the numbers, they're a mirror. You plug in different answers, and you get wildly different outcomes. One guest says there could be millions of civilizations out there. Another says we might be alone. But here's the thing. Even one other civilization would change everything, because it would mean we're not a fluke, that the universe wants life, that we're part of something larger, a cosmic ecosystem, a community we haven't met yet. And if we are alone, then this tiny blue world, this flicker of self-awareness in a cold, dark sea, becomes infinitely precious. Either way, the question matters. It reveals who we are, what we fear, what we hope for, and maybe what's waiting in the silence. So far, we've explored stars, planets, distance, and even silence. But there's a point where questions become too large to sit still, and that's where we are now. Because if the universe is ancient, full of stars, full of planets, and yet completely silent, then maybe the problem isn't out there. Maybe it's us. Maybe it's our assumptions. Maybe the universe isn't what we think it is. Let's start with one of the most mind-bending ideas. What if we're inside a simulation, not a metaphor, a literal, programmed construct? If reality is computational, like a game or a lab experiment, then the reason we don't detect other civilizations might be because they've been edited out, hidden, muted, or never rendered in the first place. Some thinkers argue that if civilizations ever become advanced enough to simulate entire universes, then it's likely that most conscious beings exist inside one of those simulations. And if so, how would we ever know? Here's another. Alien civilizations might be invisible by design, not because they're weak, but because they're too strong. Advanced species might operate on scales, or in wavelengths we can't detect. They might use quantum networks, gravitational waves, particle fields. They could be here everywhere, and we'd never know. Or they might cloak themselves, on purpose. If the dark forest idea is true, that shouting into the cosmos is dangerous, then hiding is the only way to survive. The quiet ones might still be out there, watching, waiting. There's also the zoo hypothesis, the idea that Earth is being deliberately avoided, that intelligent civilizations do exist, but have chosen not to interfere. We are animals behind glass, a cosmic reserve. Then there's the most terrifying explanation of all. We're too early. That life, intelligence, even curiosity, is only just beginning to bloom. Maybe the universe needed time. Maybe conditions are just now becoming right for consciousness, and we are among the first sparks. If that's true, then we're pioneers, but also custodians. We carry the weight of being the only voice the cosmos may currently have. These explanations might sound like science fiction, But they're not wild guesses, they're models, thought experiments, philosophical weapons forged to pierce the mystery of silence, and they share a strange common thread. They all shift the focus from what's out there to what are we really. Maybe the silence isn't empty, maybe it's structured, designed, glitched, or still waking up. And in the absence of an answer, we're left with a haunting possibility. The universe is either full of life, or it's just us. And either way, the implications are staggering. We've talked about stars, galaxies, the visible, the luminous, but most of the universe is missing. Not in the sense that it's gone, but that it's hidden, silent. It doesn't shine, it doesn't glow, it doesn't reflect light or emit heat, and yet it's there, holding everything in place. We call it dark matter. It's not just a placeholder, it's a necessity. Without it, galaxies would fly apart. Their stars would spin off into space, like sparks from a grinding wheel. But they don't. They hold together, because something unseen surrounds them, a massive, invisible halo. We've mapped it, not directly, but by watching how galaxies rotate, how light bends around clusters, how the cosmos expands. It's always there, a gravitational fingerprint without a face. What is it? We don't know. It's not made of atoms, not dust, not gas. It doesn't behave like anything we've seen in a lab. It's matter, but it doesn't interact with light. We can't see it, we only see what it does. And there's more. If dark matter holds galaxies together, something even stranger pushes them apart. Dark energy. Where dark matter pulls, dark energy expands. It is the force behind the accelerating growth of the universe. The reason distant galaxies are racing away faster and faster, a kind of anti-gravity. Not just in space, of space. Together, these two mysteries, dark matter and dark energy, make up over 95% of the universe. Think about that. Everything you've ever touched, tasted, built, destroyed, loved, the atoms that make up every star, every world, every life, are just the final 5%. We are shadows, dancing in the light of a deeper unknown. And yet from that 5%, we've begun to map the 95. With telescopes, math, collisions in underground labs, and simulations run on supercomputers, we shape the outline of the invisible. The universe is not made of what we see, it is made of what holds things together, and what tears them apart. And once you realize that, everything changes. You begin to ask different questions, not just what's out there, but why does anything hold together at all? Why is there something, instead of nothing? What's underneath reality? We've spent the last chapters talking about space, distance, expansion, but there's another dimension we've been quietly moving through this whole time. Time. We feel it constantly. We measure it obsessively. But what is it really? Time feels like a river, always flowing forward, but physics tells us it's more like a dimension, just like left and right, up and down. We move through time the same way we exist in space, yet we can only move one way, forward, always forward. But why? Why can't we go backward? Why does time seem to flow? One possible answer, entropy. It's the idea that systems tend to become more disordered over time. A glass shatters, but never reassembles. Smoke disperses, but never reforms. Entropy increases. It's not just a tendency, it's a law. And that increase in entropy gives us an arrow, a direction, past, a future. But here's the twist. The laws of physics don't care. They work just as well in reverse. A movie of particles moving backward would still obey all equations. Time itself, in math, has no preference. So where does the arrow of time come from? It may come from the Big Bang, a universe that began in extreme order and has been unraveling ever since. Time, as we know it, may be the residue of the universe's birth, but time is flexible. Einstein showed us that time is not constant. It stretches, it slows, it bends under gravity. The stronger the gravity, the slower time moves. Near a black hole, seconds stretch into centuries. Time and space are part of the same fabric, space-time. You don't just move through space, you fall through time, and at the speed of light, time stops. A photon, from its perspective, never ages. It's born and absorbed in the same instant. For light, the universe has no duration, only position. Time is not universal, it's personal. Your time depends on your speed, your gravity, your motion. You and I age differently, if we move differently. That's not theory. It's been proven with satellites, with clocks, with beams of particles. So what is time? A dimension, a measurement, an illusion, a direction, a mystery. And in all of this, one thought lingers. If time had a beginning, could it also have an end? Could there be places, moments, phenomena where time breaks down, stops, loops? Is the future already written or still being created, second by second, thought by thought? Or are we just passengers, unable to exit the ride? So far, we've mapped galaxies, measured stars, bent space, stretched time, but behind every fact, every number, every question, there's something quietly watching. You, consciousness is the one thing we all know for certain. Not stars, not atoms, not even time. Just this: you are aware, you are not the universe, but somehow, a part of the universe has become you, able to ask about itself, and that is bizarre, because physics doesn't explain awareness. Neurons, yes. Electricity, yes. But the experience of being, of having thoughts, of remembering, of fearing, of loving, that's something else. Let's stop here. Really stop. Right now you're listening to a voice in your head, a story. But who is listening? Who is the you behind your eyes? This question, what is consciousness, isn't just philosophical, it's a scientific mystery, because we don't know where it comes from. We don't know how it happens. We don't know why the brain, when structured correctly, stops being a machine and becomes a mind. It might be emergent, like a pattern, or fundamental, like mass. Some even suggest that consciousness is woven into the fabric of the universe, like space and time, that the universe needs consciousness to exist at all. But here's the truly haunting part. If the universe is 13.8 billion years old, and if life only arose on this tiny planet, and if consciousness only emerged recently, then that means for almost all of time, the universe existed in silence. No thought, no awareness, no reflection, just stars, collapsing, exploding, without anyone to notice. Until now, until you. Think of that. After billions of years, the universe produced a creature that could look at itself, measure itself, question itself. You're not just in the universe, you are the only known window through which it can see itself. And that makes you rare. Maybe not unique. Maybe others are out there. Other eyes, other questions, other dreams. But so far, we've seen none. Which means your mind matters more than we ever imagined. Who are you really? Not your name, not your face, not your story. Strip away the memories, the language, the culture. What's left? Just a flicker of awareness, the silent observer, the thing inside you that knows it's here. That is the self. But where does it begin? And where does it go? In a universe of stars and entropy, black holes and redshifts, the strangest thing might be this: a mind that knows it's temporary, a being aware of its own end. No star knows it's dying, no planet grieves, but you do. You know that time is passing. You know you won't last forever. You feel it, and that knowledge, the awareness of impermanence, is the price of consciousness. It hurts, but it also creates meaning. Death isn't just an end, it's the frame that makes the moment sharp, beautiful, urgent. If we lived forever, would anything matter? And yet the mind rebels. We fear it, we fight it. Every story we've ever told, religion, art, science, is in some way a reaction to the fact that we are conscious and finite. But here's the strange twist. Everything you've ever been is made of atoms, ancient atoms. The hydrogen in your body was forged in the Big Bang. The carbon in your bones cooked inside stars. You are made of dead things, and yet somehow you are alive. And when you die, those atoms go on. They don't vanish. They don't stop. They return to the cycle, from dust to dust, from thought to silence, from silence to stars. So maybe consciousness is not a thing that's lost. Maybe it's a pattern that arises when the right conditions bloom. A wave, not a particle, a ripple in complexity. If that's true, then death is not a deletion, it's a release, and the universe, vast, dark, expanding, might be capable of producing this flicker again, somewhere else, in someone else, or maybe in some new form beyond anything we can comprehend. But for now, you are the only evidence we have. You are the miracle in the math, the fragile pulse in an indifferent cosmos. And maybe, just maybe, that's enough. No longer floating through stars and distances, but through something more intimate, value, the unspoken weight behind every question. Because once you know the universe is vast, and life is rare, and consciousness is temporary, another question begins to burn. Does anything matter? What's the point of kindness, of beauty, of thought, in a cosmos that will one day go cold? Why care about joy or grief, or art, when the stars themselves will die? What is one breath worth when there are trillions of empty worlds where breath has never happened? This is the edge of cosmic depression, a cliff where meaning seems to fall off. The silence of the universe isn't just physical, it's emotional. We cry out for significance, and space echoes nothing back. And yet we still love, we still dream, we still stare at the sky and gasp, not in fear but wonder. And maybe that is the answer. Maybe meaning isn't found in the universe, it's brought to it. Maybe we are not here to find purpose, but to invent it, to pour it into the cracks, to build it, fiercely, like a fire in the dark. The fact that the universe doesn't assign you a reason is your superpower, because that means you choose. You choose what matters. You choose who you are. You are not here to be measured. You are here to mean. And look what we've done with that freedom. We've written symphonies, fallen in love, painted the stars. We've sent robots to other planets, cured diseases, held dying hands, cried at poems. We've taken the chaos of physics and turned it into compassion. No other creature, as far as we know, does that. So if meaning is rare, so what? So is gold. So is light in deep space. So are you. The universe doesn't owe us purpose, but somehow we give it one anyway. And that changes everything. You build something, you speak a truth, you love someone, and you wonder, will it last? That question hides inside every act of creation. Every sculpture, story, or whisper in the dark is a quiet rebellion against time. Because deep down we know, everything fades, empires fall, stars burn out, even memory slips. The universe is ruled by entropy, the great unbuilder. It ensures that over time, energy spreads, structure dissolves, heat evens out. It's why ice melts, why fire dies, why no machine runs forever. And one day, it's why the universe itself may grow cold and dark. But still, we build. The pyramids, Voyager's golden record. Songs passed from voice to voice. Digital libraries encoded in crystals. A message written in binary, drifting out of the solar system toward no one. Why? Because even if we can't stop time, we can leave fingerprints in it. Not permanent ones, but long enough to echo, to ripple forward, to remind some future intelligence, or maybe just the void that we were here. We thought, we dreamed, we reached. There's a strange nobility in that. Consider Voyager 1, launched in 1977, now over 14 billion miles from Earth. It carries images, greetings, music, a time capsule in the dark. It will drift between stars for billions of years, long after Earth is gone, long after the sun is cold, and maybe nothing will ever find it. But that doesn't matter. What matters is that we sent it, that we said we existed, we tried. So what survives? Not the buildings, not even the species, maybe the story, maybe the act of caring, maybe the choice to create beauty, despite knowing it might not last. And if all that disappears, if entropy swallows every word, every memory, every piece of art and architecture, then perhaps what matters is that it happened at all. You lived, you thought, you burned with consciousness in a universe that didn't ask you to. And that is something. For centuries, we've looked up and wondered, is anyone out there looking back? Not just stars, not just planets, but minds, questions, stories, a gaze returning our own. It's the most ancient hope of all spacefaring creatures, that we are not alone. But what would it mean to actually make contact? Not with microbes or fossils, but with a civilization, with a species that knows it exists, that has built tools, language, maybe even stories. Maybe they've stared into their own night sky and asked the same question. We often imagine first contact like a scene from fiction, ships, greetings, translation. But the truth would be stranger, because if we ever did hear from an alien intelligence, it would likely be a signal, a pulse, a burst of data sent long ago, across vast light years. It could arrive as radio waves, a laser, a burst of neutrinos. By the time it reached us, the senders might already be gone. Still, we'd decode it, analyze it, obsess over it, because even a fragment, a word, a number, a pattern, would be everything. It would prove we are not a fluke, not a cosmic accident. It would connect us to something larger, older, parallel, and yet, there's something sobering in that dream. If they're more advanced, the gap between us might be insurmountable. We might be like ants receiving a broadcast from a cathedral. We might not even recognize it as language or meaning. And if they're less advanced, if we find ruins or echoes or dead signals, we become the elder voice, the keeper of memory. In either case, contact would change everything. Our religions, our science, our understanding of life, purpose, time. We'd stop thinking only about Earth. We'd begin to see ourselves not as nations or tribes, but as a species, a single voice, echoing across the stars. Even the attempt matters. SETI, METI, golden records, deep space beacons. They're not just about finding aliens. They're about defining ourselves. What do you say to someone you've never met? What do you send to the stars? Music. We wondered. We reached. What if no one answers? What if we send messages, launch telescopes, scan skies for centuries, and hear nothing but the quiet hum of physics? No contact, no signal, no ruins, just silence. It's easy to feel disheartened by that, to imagine an empty cosmos, cold and indifferent, to believe that we are alone, stranded on a pale blue island surrounded by an ocean of stars that will never speak. But maybe we've been looking at it the wrong way. Maybe the silence isn't rejection. Maybe it's an invitation. If we are truly the first or the only species to awaken, then we are the voice the galaxy has been waiting for. The story that's just beginning. The torchbearers in a universe not yet filled with song. That means this moment, our moment, carries unimaginable weight. Because what we do next matters. Will we turn inward, divide, destroy ourselves before we leave the cradle? Or will we reach outward, build, explore, learn, survive long enough to become the ones who send messages to future minds? Imagine this, 1,000,000 years from now, a young species, just learning to listen, hears a signal, ancient, simple, unmistakable. You are not alone, we were here, and we made it. That signal could come from us. We could be the first page in the book of galactic civilization. We could be the myth, the memory, the voice that survives. And if that possibility exists, even faintly, then our job is clear. We must earn our place in the story, not just through technology, through wisdom, through kindness, through art and music and science, through everything that makes consciousness beautiful. Because if we are the first, we set the tone. The cosmos doesn't give us purpose, but it gives us time and space and silence. What we do with that silence, that's on us. We often think of the future as tomorrow, or next year, maybe a century ahead. But what about 1,000,000,000 years from now? What does the universe look like? Not for us, but for time itself. Let's begin with stars. Our sun has about 5 billion years left. When it dies, it will swell into a red giant, then collapse into a white dwarf, a hot ember slowly fading in the dark. Other stars will do the same. The massive ones will explode into supernovae, leaving behind neutron stars, or black holes. The smaller ones will quietly flicker out. Over trillions of years, the night sky will dim. Galaxies will change too. They'll collide, merge, settle into massive elliptical structures. The Milky Way and Andromeda will become one, a giant silent swirl of aging stars. Eventually, star formation will stop. The raw material, gas and dust, will run out, and new stars will no longer be born. That's when the universe enters the degenerate era. Black dwarfs, neutron stars, rogue planets drifting between dead suns, a cold, sparse graveyard of what once was. But it doesn't end there. Over unfathomable time spans, even those remnants will vanish. Black holes will evaporate through Hawking radiation, their mass slowly leaking away over quadrillions of years until not even gravity remains. And then only darkness. No stars, no light, no energy, just a thin, cold fog of particles stretched across an ever-expanding void. This is the heat death, the universe's final whisper. No chaos, no fire, just stillness, maximum entropy, a perfect silent equilibrium. It's hard to imagine, harder still to accept, a place where even memory fades, where time itself continues, but nothing happens. And yet here we are on a small planet, in the early universe, thinking about its end. That is miraculous, because even if the future is dark, we are the light now. We are the meaning, the motion, the music, and maybe that's the point. To burn brightly, not forever, but fiercely. To be conscious while the universe is still young enough to care. We are not the finale, we are the opening act. So we've traveled to the edge of the cosmos. We've watched stars die, galaxies fade, and time stretch into stillness. And now we return to this moment, to you sitting here, breathing, listening, alive. The universe doesn't care what you do. It won't punish you. It won't reward you. It won't applaud your dreams or mourn your mistakes. But you care, and that changes everything. Because if all of this stars, atoms, consciousness, language, is truly temporary, then you are the rarest thing of all, a creature aware of its own impermanence. And here's the truth. The size of the universe doesn't diminish you, it dignifies you. The fact that you are small is what makes your choices powerful. The fact that your time is brief is what makes your time precious. Every act of kindness you offer, every truth you tell, every life you touch, every piece of art you create is done in defiance of cosmic silence. It's a flare, a fingerprint, a ripple of intention across an ocean of indifference. And maybe that's what makes us special. Not that we understand the universe, but that we care about it. We give names to stars. We build telescopes just to watch light from a galaxy 13 billion years away. We fall in love under the sky. We send poems into space. We wonder. We've walked through stars, drifted beyond galaxies, stood at the edge of time. But now we're back on Earth. The air is warm, your chest rises, your heart beats once, then again. And suddenly the question becomes not how the universe works, but what you choose to do with the tiny slice of it that you've been given. Because here's the truth. We live in a universe that's old beyond comprehension, expanding, cooling, slouching towards stillness. But in this fleeting moment, you are alive. You are matter that can feel, a pattern that knows it's a pattern. The stars built you, yes, but you can now look back at them and whisper something they never could. I understand. So what do we do with that? Do we build, destroy, dream? Do we turn inward, obsessed with smallness and survival? Or do we reach toward knowledge, toward empathy, toward each other? The universe doesn't care. It has no preference. But maybe we should. Maybe the meaning of life isn't written in the stars, but in what we choose to protect, what we choose to imagine. Maybe the purpose of a conscious species isn't to live forever, but to make something worth remembering before it's gone. Because if we really are alone, if no one is watching, if no signal ever comes, then everything we do matters more, not less. Every act of kindness, every discovery, every poem, every shared moment under the night sky, they are not small things. They are everything. They are the only parts of the universe that know they exist. So maybe in the end, the question isn't how big is the universe, maybe it's how big is your response to it. You have this one lifetime, this one mind, this one chance to be a spark in the dark, and you're not alone. We're here too, thinking, asking, reaching with you. Let's go back to that ridiculous, brilliant line. You may think it's a long way down the road to the chemists, but that's just peanuts to space. At first it was funny, a cosmic joke. Now it feels like an understatement, because after tracing the edges of time and light, walking the structure of galaxies, bending through black holes, and spiraling into consciousness, one truth becomes impossible to ignore. You are tiny. But that's not an insult, it's a revelation. You are not insignificant despite your size. You are significant because of it. Because in this vast, uncaring expanse, you care. You search, you wonder. You ask questions no other creature, no star, no atom has ever asked. And somewhere in all of that, the scale flips. The road to the chemists becomes beautiful. The ordinary becomes sacred. The morning sun on your skin isn't just weather, it's a star 15 million kilometers away, flooding your cells with energy forged in a nuclear heart. The water in your glass is ancient hydrogen, born in the Big Bang. The iron in your blood is supernova dust. Your breath is recycled stardust. Everything is vast, but you are aware of it, and that makes all the difference. We zoom out, not to lose ourselves, but to find out where we really belong. Not at the center, not above, not below, but within. The universe isn't a thing we live inside. It's a thing we are part of, and a part of us. So the next time you walk down the street, look up, not for answers, but for context. You're not just moving through a city or a planet. You're moving through a living miracle, a brief flare of thought in a universe mostly silent. But maybe, just maybe, it's listening now. Everything we've explored, stars, atoms, galaxies, time, life, it all leads here, to the edge of wonder, not the edge of knowledge, because knowledge has edges, but wonder doesn't. By now you know the facts. The universe is 13.8 billion years old. It's expanding. It's massive. It's cold. It's dark. You are made of stardust. You are temporary. You are miraculous. But facts are not the end. They are the doorway. Because after all the data, all the theories, all the stunning realizations, something remains, a silence that no formula explains, a weight behind the stars, a feeling that something is still missing, not because the universe owes us meaning, but because we keep asking for it anyway. And maybe that's the last great paradox. We are creatures who evolved to survive, to eat, to run, to reproduce, and yet here we are, talking about infinity, grieving stars, crying at galaxies, longing for connection with things we've never seen. We were born for breath and heartbeat, and yet we ache for eternity. And that aching, that reaching beyond what's necessary, what's explainable, that might be the most extraordinary thing the universe has ever done. It made something that asks, and here's the final twist. Every time we get close to answering the big question, how big is the universe, a bigger one takes its place. What came before it? Why is there something instead of nothing? What is beyond space and time? Where does the edge end? No one knows. Maybe no one ever will. And maybe that's perfect, because mystery is what pulls us forward. Not just the size of the universe, but the size of the questions it leaves behind. You are not lost in the cosmos. You are lit by it, briefly, brightly, now. And maybe that's the one thing the cold, expanding void can never produce on its own: wonder. So what now? Live, create, connect, tell stories, build bridges, ask questions no one else dares to ask. Be kind, not because the universe demands it, but because you choose to be. And when you look up at the stars tonight, don't feel small, feel rare, feel temporary, feel awake. This is your moment. This is your chapter in the cosmic book, and no one else gets to write it but you. Let's stop counting. No more distances, no more timelines, no more parts. Just this, you, here, now. After 30 chapters of stars and silence, of equations and awe, the mind is full, but something deeper stirs. Not thinking, not understanding, just a kind of stillness, a soft hum in your chest, because you've felt it by now, haven't you? The truth hiding beneath every number. This wasn't a documentary. It was a mirror, and through it you've seen something larger than the universe. You've seen yourself. You are small, but not meaningless. You are temporary, but not irrelevant. You are a flicker of consciousness, so brief, so delicate, but carrying questions that could echo into the bones of the cosmos. In a universe where galaxies live and die without ever being noticed, you noticed. That alone is extraordinary. So here, at the edge, we leave you with no answers, just a feeling, a tension between fear and wonder, a silence you can't quite explain, a tear you didn't expect, and maybe a smile. Because the point of this story was never to explain the universe. It was to remind you that you're a part of it, a rare, fragile voice inside a vast, unfeeling song. And still, you sing. So if the universe feels stranger now, or maybe a little more beautiful, consider liking and subscribing to Late Science. There's always more waiting. There's a border you've never touched, but it defines everything you know. It's called the cosmic horizon, the edge of the observable universe. Not a wall, not a place you can travel to, but a limit, a boundary drawn by light, by time, by the speed of causality itself. It's the farthest distance from which light has had time to reach us since the beginning of the universe. Roughly 46 billion light-years in every direction. That number sounds final, concrete, but it's not, because beyond that edge, beyond the visible, is something we can't yet see, can't yet measure, but know almost certainly exists. More galaxies, more matter, more space, possibly more versions of reality altogether. That's the hardest part to comprehend, that what we've seen, everything we've mapped, photographed, simulated, touched with radio waves and telescopes, is not the whole, it's barely the beginning. A grain of sand in a beach of unknown size, a drop of dew on the edge of a cosmic storm, and what lies beyond, no one knows. It could be more of the same, an infinite stretch of stars and voids, clusters and filaments repeating forever. Or it could be stranger, regions with different laws of physics, different particles, different versions of causality. It could be curved back on itself, folded, stitched together with dimensions we can't perceive. Or it might end, abruptly, unimaginably. But here's the deeper truth. The edge we speak of is not just physical, it's philosophical, because the observable universe isn't just the edge of what we can see, it's the edge of what we can know. And standing at that edge, we are left with a question that haunts all thinking beings. Is this it? Is what we know all there is, or is there something beyond, unreachable, unknowable, yet still real? It's the kind of question that doesn't just challenge science, it challenges humility. Because we must learn to live with not knowing, to breathe in mystery, to make peace with limits. But in that surrender, something beautiful happens. We become explorers again, not of lands or planets, but of questions, of meaning, of curiosity itself. And maybe that's where our greatest purpose lies, not in answers, but in the act of reaching, in wondering, in not being satisfied. We stand at the edge of the visible universe, not with maps, but with imagination. And that's enough for now. There is a question we've avoided, not because it's forbidden, but because no amount of data can answer it. It's not about galaxies or atoms, not about distance or time. It's about what lies beyond knowing. We've traveled billions of light years through this story. We've collapsed stars in our minds, stretched the fabric of space, traced the breath of consciousness, and faced the end of time. But eventually, every map ends in a blank space, marked not with coordinates, but with silence. And in that silence, something lingers, a final paradox. Because the more we learn, the more we zoom out, measure, discover, and understand, the more we realize how little we truly know. The horizon moves, but we never catch it. Every answer births a deeper question. Every breakthrough reveals a wider darkness. So what is this feeling? This ache behind your ribs? This stillness that's not quite peace? This flutter at the edge of comprehension? It is wonder, but it's also fear. Because if the universe is infinite, then so is your insignificance. But if it's finite, so is your meaning. If we are alone, then we are unbearably precious. If we are not, then we are just one voice in a vast choir we cannot hear. Either way, the truth is unbearable and beautiful, and it won't stop echoing. What made the universe? Why does it exist at all? What is the origin of the laws that govern everything we've seen? Is there something beyond this? Something outside of existence? We don't know. We may never know, but we keep asking, and maybe that's the point. Because in a universe filled with blind forces and indifferent stars, here you are asking impossible questions, dreaming, grieving, building meaning from a dust cloud lit by fusion. You don't just exist, you wonder why you exist, and that's the most powerful force in the universe. You are not a conclusion, you are a continuation, a story that refuses to end,
even when the last page is unreadable. A flicker that will burn and question and reach, no matter how dark the night becomes. So here, at the final edge, we leave you not with a period, but with a pause. Because the greatest question the universe gives us is the one it never answers. And maybe that's the most human thing of all, to stand at the edge of forever and ask one more time, what else is out there? The screen fades to black. No more visuals, no more numbers, just the sound of your own breathing, and the universe still out there, humming beyond your comprehension. You've come a long way, not in space, not really, but in something deeper. You've expanded the boundaries of your mind, stretched your imagination to the edge of time, faced mortality, mystery, the unbearable size of everything, and somehow you're still here, not broken, not lost, but wider. That's what wonder does. It doesn't answer the question, it deepens it. It doesn't bring peace, it opens you. The greatest gift of the universe isn't knowledge, it's perspective. You are here for a blink, and yet somehow, that blink holds entire galaxies. You are made of fragile flesh and neurons, and yet you contain stories the stars cannot tell. The universe is not yours to conquer, but it is yours to witness, to marvel at, to carry in your chest like a secret fire, and maybe if you're lucky to pass it on. Because wonder is contagious, awe echoes. Questions live longer than answers, so share this feeling. Tell someone, not the facts, not just the billions of light years or dark matter or entropy. Tell them what it felt like, to be small, to be aware, to be a question, walking through the dark. And if anything in these past 2 hours moved you, if a thought haunted you, if a line lingered in your chest, if your idea of reality cracked open just a little, then like this video, leave a comment, subscribe to Late Science, not for us, but for the next person, the next mind, the next flicker. There is so much more waiting, but for now, we rest. You are not in the universe, you are not separate from it. You are the universe asking itself what it means to be, and that question is still unfolding.